Good morning, guys. Happy Easter for everyone. Today, we'll complete our revision on the quarter 3. In the last revision, we explained the first 3 lessons, which are speed and motion, acceleration, and forces. Today we will complete the rest of lessons. Pay your attention with me. In this diagram represent distance and time graph. Okay, distance and time graph. D and T. D and T are physical quantities. They describe the speed. Okay, what is the question? This distance time graph shows the speeds of 4 toy cars. We have 4 toy cars. Okay, the toy number 1 start from 0 reach to 6. Okay, toy car number 2 from 0 to 8. Car number 3 from 0 till maybe 6.2. Last car from 0 till 4. Which car is the fastest? Okay, we want to know what is the fastest car from the 4 toy cars. To calculate the speed of each one, we must remember the law of speed. What is the law of speed? Law of speed is distance, excellent, distance divided by time, or distance over time. Firstly, the car number 1. To determine the speed of each one of them, you must know the slope in the graph. How can you find the slope? You start with distance, okay, because it's up. So the distance in the first car 6. Okay, so there is interaction, so you can go down, so it will be 6 over 1. 6 over 1 equal 6. The last car, the second next car, 8 divided by maybe 2.5. okay, 8 divided 2.5 equal 3.2. Don't forget the result of the first car. First car 6, second car 3.2. The third one 6 over maybe this point is 6.8, so it will be 6 divided by 6.8. The result is 0.88. So the first car 6, okay, the second one 3.2, the third one 0.88. The last one 4 over 6. The result is 0.66. Okay, let's remember the speed of each one. The first one 6, second one 3.2, third one 0.88, the last one 0.66. So the first car is the fastest one, so we will choose the choice number A. Okay, the next question. The diagram below shows the forces acting on a sneaker. As the force F is applied, the sneaker doesn't move. Okay, we can see that the sneaker affected by force here and force and force. So we have more than one force, so it will be net force. It will be net force. We say that the net force is the combination of all forces acting on the same body. If the forces in the opposite direction, it will be subtracted, the smaller one from the biggest one, the smallest from the biggest. If the forces in the same direction, it will be added. But you can notice that this force acting from this direction, this force act from this direction, this force act from this direction. Okay, the question, the sneaker doesn't move. Why the sneaker doesn't move? Maybe all of these forces are similar. For example, when we have two same forces, okay, two persons, one of them sorry, push you from left side and the other one pushed you from the left side, one of them right and left. So maybe you can't move if the forces are similar or equal. So the sneaker doesn't move because the net force equal 0. Okay, and the forces are balanced or equal, so each one affect on the other one. Each force affects on the effort of the other force. Okay, so the answer will be letter D. Next slide. Tyrone wants to determine how fast a bowling ball travels when it is pulled. He uses a stopwatch to record in seconds the time it takes for the bowling ball to reach the pins. Which unit would be most appropriate to measure the length of the bowling lane? Okay, the length of the bowling lane, meaning the distance. We have three measuring units for the distance. If the distance is very short, we can use centimeter. If it large, we can use meters. If it very large, we can use kilometers. So the distance of the bowling lane is not short and not very large, it medium, so we can take or choose the measuring unit meters. Next one, the kinetic and potential energy. what is the meaning of potential energy and what is the meaning of kinetic energy. The meaning of kinetic energy, the work done by object during motion. The work done by object during motion. For example, when you kick the ball, you make kinetic energy because the ball after your kick is moved. Okay. Another one, when the goalkeeper catch your kicking ball, okay, or change its direction. So it is example of kinetic energy. The potential energy is the stored energy inside an object. For example, when you throw a tennis ball, you hold the ball with your hand for few seconds, right? During holding the ball, the tennis ball, you act by force. This force transfers from your hand to the ball in the form of energy. And when you throw the ball, this energy that's stored inside the tennis ball make the movement of the ball. In this example, the stored energy inside the tennis ball is potential energy. Potential energy meaning the stored energy. All objects have stored energy, but in the case of rest, that means potential energy different than kinetic energy, because potential energy object doesn't move, kinetic energy object move. Okay, so kinetic energy is the work done by object during motion, and potential energy is the stored energy inside an object due to the work done on it. Okay, which of the following has kinetic energy? We need example of a kinetic energy: a book sitting on a shelf, hat and gloves on a table, a child kicking a soccer ball, cars parked in a parking lot. Letter A, letter B, letter D, there is no movement, right? So we say that kinetic energy must object in case of motion. So the letter C will be the right answer. A child kicking a soccer ball. Next one. What term describes the energy that is stored due to the height of an object from the ground? Stored energy. We hear this word before. Excellent. We say that stored energy is the potential energy. Okay, you search for the potential energy. Yes, letter number D, gravitational potential energy. Number 3, 3 rocks are rolling down a hill at the same speed. Rock number 1 has a mass of 1 kilogram. Rock number 2 has a mass of 1.5 kilogram, and rock number 3 has a mass of 3 kilograms. Which rock has the most kinetic energy? If you remember that in the last video of the first revision sheet, we say that the law of kinetic energy. Law of kinetic energy is have mass multiply v squared, velocity or speed squared. So we have two factors affecting on the kinetic energy. The first factor is mass, the second one speed. So by increasing mass or speed, the kinetic energy excellent increases. Okay, so to know the most kinetic energy, you must choose the biggest mass. So the rock number 3 have the largest mass, 3 kilograms, so we will choose letter C. Number 4, we have a table. The following table shows information about some data are missing from the table. Okay. What is the gravitational potential energy of object number 1? Okay. Gravitational potential energy law, if you remember, mgh, m means mass, g meaning gravity or acceleration due to gravity, h meaning height, m multiply h multiply g. To calculate the potential energy of object number 1, okay, we have mass, we have height, we have gravity. So we will multiply 4, multiply 3, multiply 9.8. The result will be 117.6, and the measuring unit of energy, all energies, is joule. So the right choose letter number B. Next one, how is mechanical energy calculated? Okay, mechanical energy is calculated, if you remember, by adding or the summation of potential energy and the kinetic energy. The law of mechanical energy is potential energy plus kinetic energy, okay, by adding potential energy and kinetic energy. So the right answer, letter A. Okay, this table cancelled. Okay, this question, a child pushes a toy car down a hill. After 5 seconds, the car has a kinetic energy of 115 joule and a gravitational potential energy of 30 joule. What is the car's mechanical energy at that time? Okay, we say that the mechanical energy is a summation of potential and kinetic energy. So we will add it 115 plus 30. So the right answer will be letter D, 145. Okay, slide number 5. The motion of a fish swimming in the fish tank is an example of which type of energy? The fish is swimming, so it moved. Okay, we just take 3 examples of energy: potential, mechanical, and the kinetic. And we know the difference between potential and mechanical and the kinetic. Potential is stored energy, while kinetic is the energy done or released or appears during movement. So a fish swimming meaning moves, so we will take letter A, example of kinetic energy. A girl uses 60 joules of energy to move a box from the floor to a shelf. How much power does she use if it take her 3 seconds to move the box? Okay, we have 60 joule of energy and we have 3 seconds of time. and we want to calculate the power. If you remember that power P equal energy divided time. Energy divided time. Energy is 60, right? Time is 3, so 60 over 3, excellent, is 20. So the right answer, letter P. Okay. Our revision sheets, or our revision sheet of the quarter 3 is finished. All the lessons. Okay, let's remember our lessons. Lesson number 1, speed and motion. Lesson number 2, acceleration. Lesson number 3, forces. Lesson number 4, work, energy and power. Lesson number 5, the last lesson in our curriculum, is potential and kinetic energy. This is the first revision video which uploaded on your LMS. You can find it at the beginning of this video. I said some laws of our lessons. You must memorize it and save it, okay, to be ready for your quarter exam. At the end of this revision, I want from you not to be scared from the quarter exam. It will be easy, inshallah, and you will get a high grades, so don't be scared from the exam. Okay, thank you for your time. See you soon. Goodbye.